Hello guys, so far in our tutorial we have seen about that DB2 instance. I spoke about the DB2 database and the ways to configure the instance parameter and database parameter, and we have also seen how we can update those parameters as well. So we have gone through all that. Now I'm going to talk about that one of the important things in DB2 is about the storage management. Okay. Now when I talk about storage management, let's see an example here now. Okay, now I'm trying to create a table here. Okay, let me test one table. Okay, it has one column. Okay, now I'm going to create this table. Okay, so behind the screen what is happening at the moment is this particular table's data will be stored in something called a table space. Okay, now here I have not specified any table space name here where my actual data is supposed to be stored. Okay, but DB2 by default it stores this data into a default table space. Okay, so you might be asking what is the table space, right? Now table space is nothing but a logical name. It's a logical name given to a data file or a group of data files. Okay, so for example I have one data file in C drive, so I will logically name, I'll give a logical name to that particular file which will be a table space. Okay, now all your table definition, whenever you create a table, so automatically it will look at the table space name and it will put the data into this data file. Okay, now it can have multiple data files. Okay, it can be C drive, D drive, E drive, but it will have a single logical name. Okay, so what basically is happening is when we create a table we have to specify a table space. Okay, if we don't specify a table space, DB2 will automatically assign one table space to the table. Okay, so again the definition will be the table space is a logical name given to a set of data files or a single data file. In DB2 we call this data file size containers. Okay, so hereafter whenever I speak about containers it means a data file. Okay, so table space is nothing but a logical name which has been to which we assign data files. Okay, it can be a single file or it can be multiple files like you see here. Okay, now when we create the database we have three different table spaces which are created by default. Okay, I'll go through those table space first. And okay, the first one is the syscat space. Okay, where all your system related information tables will be stored. Okay, so you cannot go and create user defined tables on this table space. Okay, it is strictly for the system level tables. Okay, so this is one of the default table space which is created by default. Then you have the temp space one. Okay, this is also created by default and it will be used for temp operation like sort or some any kind of temporary operation you're going to do in the database. It will use this temporary space. Okay, and similarly we have one default table space called user space one. It is created by default. So when you give the create table statement, right, and if you don't specify anything in the command, by default it will go into this table space. Okay, so if you see my earlier example where I create the table, it will be on the user space one table space because I did not explicitly I did not specify any table space here, right? So so these are the three table space which are created by default: syscat space, temp space one, and your user space one. Okay, now let's try to, for example, I do not want to create this table space on user space one, right? So I can do is just name id int in ts1. I have a table space called ts1, so I want to put this table in the ts1 table space. Okay, so it will create the test3 table in the ts1 table space. Okay, so ideally, like when we are working on a production environment or your customer environment, we will have specific table space names. Generally we don't use the default one. Okay, so we'll create one, and then we'll create the table on that table space. Now to know more about table space, let's look at the DDL, like how we create a table space. Okay, so I have one DDL here. Okay, so this is the like command to create the table space. Okay, now if you see here, it says create large table space. I'll come to the large table space in a few minutes. Okay, so basically the syntax is create large table space and the table space name. Okay, in database partition group. What do you mean by database partition group? Is like we have a concept of partitioning in DB2. Okay, so where you can have your container in one in many servers, like you have server A, B, C. So you can have one container in server A, one in B. So you can group those servers and make a partition groups. Okay, and so if you specify the partition group, like suppose you specify like the partition group should be 1 and 2, whether whereas you have 4 servers, but you want this table space to be defined only 1 and 2 servers, right? In that case, you can create default partition. You can create a partition group which will have only server A and server B, and you can specify the partition group name here. Okay, so by default it will be like IBM default group. Okay, we will see more about this when we do the partition databases. Okay, and the mandatory some of the mandatory parameters are page size. Okay, now in DB2 you can have a page size of 4 KB, 16 KB, 8 KB and 32 KB. Okay, those are the page size which are which DB2 helps. Okay, so you cannot have 64 or you cannot have 100k pages for your table space. So we have the option only for 4k, 8k, 16k and 32k. Now managed by automatic storage. I will come to that later in the slide. I have a slide for that. Okay, using okay, and we have other options like auto resize. Yes, initial size. What is the initial size you want to set for this table space? Okay, then you have the extent size. This is very important parameter, extent size, and the prefetch size. And another mandatory parameter is the buffer pool. Okay, so for example, when you create that table space, okay, the default table space size will be 4096, like the 4k page. Okay, and DB2 also creates a default buffer pool when it creates the database. Okay, now you want to create a table space with a 8k page. Okay, so before you create the table space with 8k page, you need to make sure that you also create a buffer pool with a 8k page size. Okay, so you cannot use a buffer pool which is of 4k size for a 8k or a 16k for a 8k buffer pool. Okay, so make sure if you create a 8k table space, before that you have to create a buffer pool of 8k size. So similarly, for 16k means you have to create a 16k, 32k means 32k. Okay, so some of the very important parameters: the page size, the buffer pool, the extent size. Okay, now let me go through the extent size first. Okay, now I told you table space is a logical name, and you basically assign a data file to the table space, right? Now in case of single file, it's very much easy, like we know that the data will be continuously written into a single file, right? Now what happens when you have multiple files? How the data is written? Like for example, here we have C drive, D drive, E drive, right? So how the data is written to these data files? Okay, now in case of DB2, it does this on a round robin fashion. Okay, so first it will write here, then here, and then this page, okay, equally. So how that happens? Now we saw the parameter called extend size, right? Now if you consider this particular box as a table space, logical name given to a table space, it is subdivided into pages. Okay, small blocks are nothing but pages. Okay, in this case I have two containers, 1 and 2 for a table space, and I have defined my extent size equal to 2. So if you go to the command, right, you see here it is set to 32. Okay, but in my example I'm just setting the extent size to 2. Okay, now when I set the extent to 2 means 1 page and 2 page. Okay, 2 pages of this table space will make 1 extent. Okay, so basically you're grouping the number of pages in a table space. Okay, so when I say extent size equal to 2, it means 2 pages from that container. Okay, so for example, when you're writing data into this container first, okay, so first it will fill up the first 2 extents, because we have set this extent size to 2, right? So first it will write here, then here. Okay, and any other request which is coming there for this table space, it will go to the next extent, which will be on the second container. Okay, then again it will write 2 pages there, again it will move back to your next extent on the first container. Okay, so it happens in the round robin fashion. Every 2 page it will move the pointer to different containers. Okay, so similarly if you have more containers, then it first will write 1 here, 2 here, then 3 here, then 4 here, again it will come back here again. So it's like a round robin fashion depending on your extent size. So if I set this to 3, then it has to write 1, 2, 3 and then move to the second container and write there like 1, 2, 3 and come back again here. Okay, so your container is basically divided into logical pages. Okay, then again those pages are grouped into extents depending on the extent size. Okay, I hope this is clear, like how your data is written in a round robin fashion in DB2. Okay, so that is the use of extent. Now there was another parameter which I said is very important, is prefetch size, right? Now in this case it is set to automatic, but the thumb rule to set a prefetch size is, for example, if you have 2 containers and your extent size is 2, right, then your prefetch size ideally should be extent size into the number of containers. Okay, now in this case it is set to 2 and we have 2 containers, so the prefetch size should be 4. Okay, and so in this case the prefetch size should be 4, right? So how it helps your performance, how the prefetch size improves your performance? We know something called prefetches, right? When we did the architecture, I spoke about prefetches, where your prefetches will read the data from disk and move it to your buffer pool, right? So in this case, when we set the prefetcher size to 4, okay, it will take this page, this page, this page and this page at the same time in a one single IO or CPU cycle. It will move all these 4 pages at once to the buffer pool. Okay, so most of the time, like the sequential data will be in like continuous pages, right? So it is basically the algorithm which DB2 uses to prefetch your data from your table space to the buffer pool. Okay, so if, for example, if you set the extent size to 2 and you set the prefetch size to 1, then it can just move, it will just move this in one cycle and it has to do another cycle to prefetch this data. Okay, but if you set this to 4, that means 2, prefetch size to 4, then it will just take on all the pages at the single CPU cycle or IO cycle, whatever it is. Okay, so more data is fetched at the same time. So that was the use of the prefetch. Okay, so extent size and prefetch size. Prefetch size should be set to extent size into the number of containers. Okay, now I spoke about one more parameter there, like the large table space, right? Why we creating a large table space? We have a different size limit when you specify a regular table space or a large table space. So for example, if I set the size to 4 KB of the table space, then if you create a regular table space, it means that you cannot grow beyond 64 GB. Whereas if you go with the large table space, you can have a 2 TB of space for the table space. You don't have to worry like to add more containers or anything like that. Okay, so we have a higher limit when you have a large table space. So similarly for 4K it is 64 GB on a regular table space, and in case of this it's like 8 TB, and for 8K it is 128, here 16 TB. So when the page size increases, automatically your limit will increase. Okay, so here the size limitation is for version 9 and 9.5. okay, this is the version 9.7 max limitation. Okay, now again coming back to the table space definition, right? In DB2 we have two kind of table spaces. One is the DMS table space and another is the SMS table spaces. Okay, now the thumb rule to when to use SMS table spaces, like when you create your database, your system tables can be on a SMS table space, and your temporary table space can be on a SMS table space, like it can be SMS table space. Okay, that will be the thumb rule. And for all your data related or index related data, you have to use the DMS table space. There's a lot of flexibility which comes in a DMS table space which we don't have in SMS table space. Okay, now when you use SMS table space, if you run out of space, it is not possible to add another container in SMS table space, whereas in DMS table space you can always go ahead and add the containers. Okay, and SMS table space, when you use SMS table space, for every object, for example, if you have two tables on that particular SMS table space, those two tables will be stored separately in separate files. Okay, inside the there will be a folder inside that. If you have two tables, like there will be two files for that two tables. In case of DMS space, it's just a single file. Okay, so if you have 10 tables, all those 10 tables will be stored in a single file. Okay, so as a thumb rule, always go with DMS for your data and indexes, and for your temporary and small like system catalog tables and all, you have to go with the SMS table spaces. Okay, and coming to the other parameter here, like no file system caching and drop table recovery on. Okay, by default in earlier versions of DB2, what used to happen is the file system caching will be on by default. Okay, so there is like two level of buffering happening on the database level. One is at the file system level, and another is happening at the your database buffer pool side, right? So already we have the data in memory plus in the file system cache, so which is like you need two cycles to get the data, right? First it has to go to the file system cache, then file system cache to your buffer pool. So in order to remove those dependency, what DB2 has come up with is the no file system caching. So in this case, the data or whatever information will not be cached to the file system, it will be directly moved to the buffer pool. Okay, so for all your data and indexes, make sure this is set to no. Okay, and drop table recovery on. This is very important parameter in case you want to recover a table which was dropped. Okay, so in this case, all additional information about the table space will be retained even after you drop the table space, table, right? So if you keep this on, in case accidentally someone is dropping your table, it is possible for you to recover that table later. Okay. So just to summarize, like we have two kinds of table spaces, DMS and SMS. Okay. And data and indexes should go to DMS, and your system catalog and the temporary table space should go to the SMS table spaces. And you have extents, okay, where you basically logically group the pages, okay, and data is written into the containers on a round robin fashion, okay. And depending on whether you use a regular table space or large table space, you have certain limitations, okay. So I think that should cover up the table space about the table space and the different parameters inside the table space configuration. Okay, so see you in the next class. Thanks for watching.